So here we have some stuff. All of these strings, according to the rules that we had, are palindromes, right? So let me solve to make the first one work, and then let's figure out why my solution is what we call naive, why it only solves one case but not all the cases. So race car is a palindrome because R and R occur in the beginning and the end, and then if we move in one space, A, and then C, and then E is in the middle, which is great. Sounds good to me. What I want my function to do is to take in a string, and then to return, I'm just going to say a bool. I'm going to say, is this a palindrome? Yes or no. All right. So now I need to return a bool. Return a bool. And all I want to figure out is the string the same forwards and backwards? Well, what I can do is I can just say, does the string equal the string in reverse? Is this going to work?
No.
Why doesn't it work, Rod?
String that reversed is not of type string anymore. It's of type string reverse thing.
Yeah. String dot reversed is a reversed collection. So if you remember, a string is just a collection of characters. Well, not just, but a string fundamentally is a collection of characters. And if we reverse it, we get this type called reverse string, reverse collection, I'm sorry. So here's something hacky we can do, but it's the easiest way to do it. So this is how I would solve for one specific case. Naive solution. This works if our string is just one word. How's that sound so far? What else needs to be true?
If it's empty.
Tell me more.
One of the cases was if the string is empty, it's true.
Okay, let's make that case. Let string 0 be the empty string. I've just got a bunch of assertions down here. Let's see when this fails. So what I want to know is, does this work for the empty string? Does it work for the race car? I don't know if it's going to work for 2, 3, and 4 just yet. Let's see when we get an error message. Cool. So this does work if our string is just one word or an empty string. However, let's add in some intermediate step. Just like with string 3, what if I've got race car? Why isn't this going to work?
It's uppercased.
Yep. So let's refine it a little. Deal with any string regardless of case. How can we do that? Ian, is there a function for strings that you can use to, I don't know, change how it works?
To change the case, you're saying?
Yeah.
Like dot lowercase or dot uppercase?
Sweet. I'm going to say just by convention, let's use dot lowercase. No real reason except that that's what we see, just like we usually see on a binary tree that we go left before we go right. That's just what people have seemed to do. Cool. So we refined it a little bit, and this should now fail when we go to test string 2. Cool. That's great so far. Why does string 2 not show as a palindrome right now?
White spaces.
Yep. There's white space. And so it's not going to work right now. How can we get rid of white space?
We use the trimming characters.
Yep. We can trim these characters. Cool. So return string 1 dot lower. Let's trim the characters first. What does this trimming characters take as an argument?
Dot white space.
Yep. So it takes as an argument some, let's look at what a character set is. It's a set of Unicode compliant characters that foundation, so that package inside of UIKit, groups characters together so that we can search in certain operations. So we can use this to get rid of this trimming characters. It should give me better info, but what it's going to do is it's going to remove from this string, str, the white space that is set up in this character set. So think of this character set dot white spaces as like a constant that you were calling on. You want to print this out and see what it does? I want to keep going.
I think you could just have
Right
dot white spaces.
Sorry?
I think you can just have dot white spaces.
Oh, cool. What is that?
Probably an enum.
So it's an enum, yeah. And because this is another, if you think about it, this is another example of type inference, because trimming characters takes in an argument that's a white space. We don't need to say character set dot white spaces. We can just instead say dot white spaces because it infers it should be looking for a character set like that. Cool so far. All right. So let's get rid of the white spaces, and then let's lowercase it, and then let's trim those characters again. And then let's reverse it. Let's see if this works. Uh-oh. What did I do wrong?
Didn't lowercase the right-hand side?
Yep. I didn't lowercase the right-hand side of this double equals operation. And what I would probably suggest is if we're going to do the same thing to the left side and the same thing to the right side before we reverse it, we should just create one instance. So I'm going to call this sanitized string, and that's where we're going to transform the string in all the ways that we need to make it look right. And then what I'll do at the end is I'll compare sanitized string to sanitized string reversed. So to make sure that whenever we make changes to clean up this string, we have the same string on the left and the right hand side, might as well just do it one time and then look at the reversed version. Let's see where it fails now. Still fails at 2. Why is that? For anyone who used the trimming characters function. Let me step back. Did anyone use this trimming characters function?
No.
No.
Yeah.
You did. Okay.
Red and I did.
Sorry.
Yeah, Red and I.
Okay. How did you get this to work? Because let's take a look at what sanitized string is. Print sanitized string. I'm still seeing some white spaces. How come?
You think trimming just remove white spaces at the end?
Yep.
Mm.
What might we want to do instead?
Replace occurrences of.
Yeah, we could do that. Say replace occurrences of. What's the string protocol here? A type that can represent a string is a collection of characters. Okay. Has anyone ever used that?
So 2 quotes with a space, and then with just 2 quotes without a space, I believe.
Cool. That sounds good. Let's print that guy out and see. Wow, look at that. Awesome. That looks good to me so far. But now we've got one last case. What is that situation?
Punctuation.
Punctuation. How can we deal with punctuation in a string? And this is where it gets a little tricky. So this one right here works for the first 5 cases. How do we handle punctuation? And what if there were just any other non-alphanumerics in there? Or any non-alpha numerics? I'm going to show you something about one of my favorite language features. This is kind of like taking a character set like we saw before. There is an alphanumerics character set, but we don't want to replace that. The nice thing is, we go to a character set, go into our foundation types, amazing. There's an inverted property. Returns an inverted copy of the receiver. What do you think an inverted character set is? So if I had alphanumerics and I took a set, think about a set. What would you say if I had a set that was all the things in the world except for 2 things? If I inverted that, what would I have?
Those 2 things.
Yeah. So an inverted set is everything except what's in that set. Which is great, because now we can say, okay, if I want to get rid of everything except for alphanumerics, I can use this character set. I can use the character set alphanumerics dot inverted to say, instead of giving me all of the alphanumerics, instead give me everything that is not an alphanumeric, and then I can remove them. Can I remove them in this replacing occurrences of? Let's try it. Can I use a character set here? Character set dot alpha numerics dot inverted. No, we can't, unfortunately. Character set has to conform to string protocol. Dang. But that's okay. There are other functions out there for strings. What other function out there lets us take a string, look for some things in it, and separate out by those string things?
Components separated by?
What's that?
Components separated by?
Ooh, interesting. Components separated by, oh, we can use a character set. What does this return to us? Components returns.
It returns an array.
Yep. An array of strings. And so let me get someone new. Jocelyn, are you there?
Yes.
Cool. So if I have an array of strings, I bet there's an array function that lets us combine all those things into one string.
Okay.
What's that?
Is it okay?
Remember?
I don't remember.
Lets us combine everything into one object.
Is it Mac?
So it's not map. Map is going to return an array of the same length.
Yeah. I'm drawing a blank.
Okay. So there's one specifically, it starts with a J. Let's start with the higher order array one. We could use a reduce. We could say reduce an empty string, and then with that empty string, just combine at each step, each thing in the array. But we could also use something Eric suggests, which is called join. So if we have an array of strings, it'll often be easy to just go ahead and combine them. Work. And then joined returns a new string by concatenating the elements of the sequence, adding the given separator between each element. Let's see where this is defined. Interesting. So this is pretty cool. There is an extension of array specifically and only when the elements in the array are a string. So if you remember, there's no magic in Swift. Everything's defined somewhere. This joined function is only available for us to use when our array has strings in it. And what else is pretty interesting about line 9504? What behavior does it give us by default?
What do you mean by behavior?
Well, what does this joined do out of the box without us having to tell it anything specific? It takes an argument, but what's going on with that argument?
It's setting its initial value to an empty string.
Yep. So there's what we call a default value as the argument, or a default argument in this join function that says, you could provide us with an argument. So joined could take an argument that's a separator, or it can just know to separate them with an empty string. So cram them all together by default. So just want to like triple down on this guy again. This is an extension of an array. So this is not in the default array definition, but instead they said, hey, we've noticed, they probably said at some point, hey, we've noticed when people use arrays of strings, they want to cram them all together. Let's just extend array. But we don't want joined to be available for any kind of array with any kinds of elements. Instead, and then this is the fun part, element is a generic. Element is like when we use a linked list and we put T, or when we use a stack and we put T. Element is any generic item that's in an array. Let's see if we can get all the way to the point where they talk about it. So an array has elements in it, and this where clause is saying only for arrays whose elements are strings can use this join. There are other extensions, as you see right here. If the array is full of elements that are equatable, then you can do this thing called the split. You can look for the first index of. So there are all these things built in by default based on what the elements of the array are. Arrays are super powerful. And the one that we're using right now is the joined. So let's see what happens when we use this joined. Oh no, what did I forget?
Lowercase.
Yep. So just based on what I printed out, our sanitized string didn't have the lowercase in it that we needed before. I'm gonna put that first, just so that I know it's there. All right, do we see any errors? Dang, does that mean they all passed? Pretty cool. Okay. So here's what we did. We went from just being able to see if a string matched that reverse string to also making sure it could be lowercase, to also making sure we got rid of any spaces, to deciding, hey, you know what, rather than figuring out if there are spaces and colons and commas and any other punctuation, we use the inverse of the alphanumeric character set to say, let's use everything that is not alphanumeric in this components as a separator. So we said, look at the string, lowercase it, do the components function, which goes and tries to split our string into an array by looking at certain spots in the array. Let's look at what we actually get here, because it's going to make a mess. I'm just going to say return true. Before we join them, when we separated out in this last example, you see we got empty strings wherever we had some other piece of punctuation. So this component separated by deals well with white space, but it doesn't know what to do if it sees something like a, I don't know, colon or a comma. And so that's why we needed the dot joined to bring it all together as a string. And our sanitized string will work the way we wanted by combining all of those empty strings with all of the alphanumeric characters that it finds.
David, I have a question.
Yeah.
Okay, so you said when we do this dot components, it turns our string into an array, and then we're looking for, when we did the alphanumerics dot inverted, it was pretty much the opposite of alphanumeric characters, right? So it was like all the stuff that's not alphanumeric. But then with this dot joined, are you saying that makes it back into a string?
Exactly, yeah.
Okay.
And the reason we want that is so that, say, like according to the definition we have of a palindrome, this is still a palindrome, but the array that we get from separating it by components would not make it into a palindrome. So we want to use the components to separate out all of the other characters, but then use the dot join to put it back together with all the letters in the right order and not as separate elements of an array. So, yeah. Letter. So each letter will, or group of letters, be an element in the array from components, and then joined is a function specific to arrays of strings that allows us to cram everything back together into one string. How do we feel about this? Cool. How else did people go about solving this? If I told you there was no reversed function, how would you go about solving it?
I didn't do this, but talked about this. Looking at the first character and the last character in the string and making sure they match. And as long as they do, it ends up being true. And if at any point that fails, then it's false.
Yeah. So that's a great approach. You could do this recursively, actually. Anyone remember if I have the string, let string equal, I should probably write that. Is this a palindrome? No. What about anana? That is. This isn't, though. You know what palindromes are. But what I could do is I could say if the string dot first index, or if the string at first index and string at last index are the same, call this function on the string, then here's where you need to use string indexing from second index dot dot less than last index. That's another good approach. You start on the outsides and you move in. How can we do this? Anyone remember anything about string indexing? Any thoughts?
So are you saying you would use a range when you're doing the recursive call?
Yep.
In the subscript?
Yep. So for a string, we can use a range so long as the upper and the lower limit are string indexes, not numbers. Let's look at one of my very favorite pages in the Apple documentation. This is the index offset by function. So if I wanted to get the fifth letter or fifth character in the string, I could use index. I could start at the start index, and I could say offset by this many. How could I get the first character? How could I get the first character in a string? So let me copy this into our playground. How can I get the first character in Swift?
You mean using this indexing?
Yep.
Well, wouldn't it be s index, s dot start index, and then offset by 0?
Yep. And how do I get the last character? S dot index. I can look up the start index. Then what would be the math to get offset by?
S dot count what character do you want?
I want the last index.
The last index, sorry, -1.
So that would be -1. And so if those two are the same, so if first is double equal to last, call this function, else and false, right? How do you think you would get the second index to feed it into here? Eric W. Here's how I got the first character. Here's how I got the last character. I'm sorry, let me be more clear here. This is the index of first character, the index of the last character, and our goal here is to be able to use those indexes to subscript our array. Because if you remember, we can't just use numbers to subscript strings. Damn it. We can't just use numbers to subscript a string. We need to use a string index. And that gets calculated with this whole process. I can then in here just say, well, if this is the index of the first character, the index of the second character is going to be the first character offset by how much, Eric?
By 1?
Yep. And then I could just call this function on string from the second index all the way up to, but not including the last index. So if you want to try to make that work, that's a great solution. You could also iterate through, of course. You could look at the first and the last, and then you can move your string index. There are a lot of ways to solve this. You could also kind of do what I did, where you have the string and you reverse the string. But if you didn't know about sanitizing your string, you could loop through both of them and then keep track of the letters that you've seen. Loop through both and compare the last character that was a letter for string and string dot reversed. What did other people do? All right. And then I think I